this is lesson 7.5, and in this lesson we're going to apply all of those skills that we've learned in the last two lessons using SOHCAHTOA to solve for angles and sides in right angle triangles, and now we're going to apply it to some application questions. In order to do that, first we need to understand two pieces of trigonometry terminology that come up over and over again when working with trigonometry, and that's angle of elevation and angle of depression. Sometimes you see angle of depression also called declination or decline, just like elevation could be inclination or incline. So if you ever see angle of incline or inclination or elevation, they all mean the same thing. Same with depression, decline, and declination. So what are they? Well, angles of elevation and depression are always measured from your line of sight. So if we look at the two diagrams, we see this person looking straight out and they can see a tree. Now if they turn their neck up and look at the top of the tree, there's an angle that's created from their original line of sight straight to the angle they have to look at to see the top of the tree. And that angle between their line of sight and their new line of sight to the top of the tree is called an angle of elevation. Conversely, if we're looking down to get to an object, if we were to look straight, we'd have a line of sight, and when we look down, we create a new line of sight to the object, which creates an angle of depression. The key is always from line of sight. Okay, now that we've seen these two, let's take a look at some applications. First, we'll do an angle of elevation question. Jessica is a forester and she uses a clinometer to measure an angle of elevation. And what a clinometer is, well, it's kind of like a big protractor with a weighted string on it. When you point it up or down at an object, you can read off the angle based on where the string is dangling. Pretty cool. We would have used them if we were working through this in class. Alas, we get to do it in a word problem. So, a clinometer. She's using a clinometer and she can measure that the angle of elevation is 48 degrees to the top of the tree based on her line of sight. Tilting up to look at the top of the tree, an angle of 48 degrees is created. She is standing 7.2 meters away from the tree and her eyes are 1.6 meters above the ground. So if we're taking into consideration her height here, we want to know how tall the tree is. Well, based off of this diagram, we have a couple things. We have a nice right angle triangle right here, so we know we can use some trigonometry. And we have a rectangle down here. The nice thing about this rectangle is that rectangles have pairs of equal sides. So if this bottom length is 7.2, so is this length of the triangle. If this side length is 1.6, so is this side length 1.6. So if we want to know the height of the tree, really, we just need to figure out this part of the triangle and then add the 1.6 meters. So let's give that a shot. Let's now just focus on this triangle. What do we have? Well, we have an angle, and if you have an angle, you can label opposite, adjacent, and hypotenuse if it's a right angle triangle, which it is. So from our angle, we can look across, and this would be our opposite. Our hypotenuse would be across from our 90. And our adjacent would be the 7.2. So what do we have and what are we looking for? Well, we have the adjacent side and we want to find the opposite side. So if we look at SOHCAHTOA, one of those three has O and A in it, and that's TOA. So we can use our tan ratio to find the opposite side. So let's name this opposite side. We're not going to name it H for height because that's not the whole height of the tree. So let's just call it X. We're going to find X. So let's write our tan equation. Tan theta equals opposite over adjacent. How did I remember that? TOA. Tan theta equals opposite over adjacent. And now let's fill in what we know. We know the angle is 48 degrees, so we have tan 48. The opposite side is what we're looking for, x. The adjacent side is 7.2. And if we want to rearrange this to solve, our unknown's on top, so we just have to multiply by 7.2. So we get 7.2 tan 48 equals x. And now we can use our calculator that's in degree mode, and we can do 7.2 tan 48. And we get 7.996. We'll round that to 8. So we get x equals 8.0 meters. And now that's not the entire height of the tree, because that's only this part, which represents our right angle triangle. We still need to add on the 1.6. So if we want the height of the tree, we need to do 8.0 plus 1.6. And we end up with 9.6 meters. So we can say, therefore, the tree is 9.6 meters tall. And there we have it. Okay, let's try an angle of depression question. Eric works for an oil company in Alberta. He needs to drill a well to an oil deposit. The oil deposit lies 2,300 meters below the bottom of a lake, which is 150 meters deep. The well must be drilled at an angle from a site on land. The site is 1,000 meters away from a point directly above the deposit. Determine the angle at which the well should be drilled. And we kind of have a little picture here. We're going to drill from this site at an angle, which we don't know, to get to our oil deposit. And that oil deposit is below a lake, which is 1,000 meters away from the point that we need to go directly down from. Now, this distance down has two parts. The first part is 150 meters to get through the water, and then below the water we have 2,300 meters. So altogether, if we add those, we have 2,450 meters. And that is our distance down. We don't want to know the distance down. What we want to know is this angle, the angle of depression. So how do we find that? Well, let's label our triangle, because we're looking for an angle. Let's label what we have. From our angle, we can go across the triangle, and this would be our opposite side, 2,450. Across from our right angle, because remember, directly down and horizontal would make a right angle. This would be our hypotenuse, leaving this to be our adjacent side. So what do we have? Well, we have the adjacent measure, and we have the opposite measure. So if we look at SOHCAHTOA, again, we have O and A, so we have TOA. So we can use our tan equation again. Our tan equation is tan theta equals O over A. At this time, we're looking for the angle. So we get tan theta equals opposite 2,450 over adjacent 1,000. And if we want our angle, remember from our last lesson, we have to use tan inverse. 2,450 divided by 1,000. And we can check to see what we end up with. Let's use our calculator. Second tan gives us tan inverse. 2450 divided by 1, 2, 3 zeros. 1000. 67.79, and determine the angle. Doesn't say anything about decimal places, so let's say 67.8 degrees. So we should say, therefore, the well should be drilled at a 67.8 degree angle. All right, and that's it for angle of elevation and angle of depression questions. If we come back for part 2, we're going to look at a 2-triangle question and a 3D triangle question. So thanks for watching, and I'll see you in part 2.